Good morning. In this lecture, we will discuss about Darcy's law. Darcy was a French waterworks engineer. He conducted a test in 1856 on clean sand. This is the setup for Darcy's law. He took the soil sample of length L and the cross-sectional area is A, and he connected this soil sample with two reservoirs, that is at a height h1, at a head h1 and head h2. Due to the difference in head delta h, h1 minus h2, water starts flowing from A to B. Before conducting the actual experiment, Darcy assumed that the soil is saturated and the flow through soil is laminar. Flow is one-dimensional. One-dimensional means the flow velocity is the same at any point of a cross section perpendicular to the direction of flow. Means it does not change its. And flow is steady, means flow parameter like pressure, velocity and head is also not changing with time. And the total cross-sectional area is used. He conducted the experiment at 27 degrees Celsius. By conducting test on soil samples, same soil, as we know, he has taken clean sand. So by conducting test on same soil and varying one of the variable, that is delta h, this delta h means h1 and h2, h1 minus h2, length, that is length of the soil sample, and cross sectional area of the soil sample at a time, Darcy established that the flow occurring per unit time is directly proportional to the head causing flow and the area of cross section. Means if the total flow is Q, flow or discharge, so flow per unit time is small q, that is Q by T. This Q is directly proportional to delta H, that is H1 minus H2, and this Q, small q, is directly proportional to area of the soil sample. But it is inversely proportional to the length of the soil sample. Directly proportional to the cross section, inversely proportional to the length of the soil sample, and directly proportional to the head delta H, H1 minus H2. So if we combine equation number 1, 2 and 3, what we get? Q is directly proportional to delta H by L. This delta H by L is called I, that is hydraulic gradient. Hydraulic gradient. So if we remove the proportionality sign, we have to introduce some constant, that is K. So equation becomes Q is equal to K delta H by L into A. This delta H by L is nothing but hydraulic gradient, and this K is called coefficient of permeability, and this coefficient of permeability changes if the soil in the tube is changed. It means this K is totally dependent on the type of the soil. Okay, so if you do Q by A, that is velocity. Q by A, discharge per unit area, is velocity. So Q by A is equal to V is equal to